Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it. Hook. Imagine you're 10 minutes into the paper. You breeze through a quadratic equation. Then you hit the inequality question, and suddenly you lose 2 marks. Not because the algebra's hard, but because you wrote the endpoints wrong. Sound familiar? This one mistake costs more marks than it should, and by the end of this episode, you'll have a 3-step routine that avoids it every time.
That's me every time. I can factor okay, but inequalities make me panic.
Promise, in the next 12 minutes, I'll teach you the reliable routine, factor, sketch, sign chart, show you why the graph tells you where the quadratic is positive or negative, explain exactly how examiners award marks, and give you a 15-second check that catches most mistakes. Let's start with the concept.
The concept. Step 1. Factor. Take a simple example. Solve x squared minus 5x plus 6 greater than 0. Written algebraically, x squared minus 5x plus 6 greater than 0. First job is to factorize. X squared minus 5x plus 6 equals x minus 2 times x minus 3. Those brackets give you the critical points, the x values that make the expression equal to 0, x equals 2 and x equals 3. Write those down clearly.
Step 2. Sketch the parabola. Because the coefficient of x squared is positive, the parabola opens upwards. That means the curve is above the x-axis outside the roots and below the axis between the roots. Say that again. For an upwards parabola, the quadratic is positive to the left of the smaller root and to the right of the larger root, negative in between. Let that picture guide your answer. Don't guess the sign.
Step 3. Make a sign chart. Put the critical points in order on a number line, -infinity to 2, 2 to 3, and 3 to infinity. Choose one test value from each interval, for example 0, 2.5 and 4, and substitute into the factorized form. At x equals 0, 0 minus 2 times 0 minus 3 gives minus 2 times minus 3 equals plus 6, positive. At x equals 2.5, 0.5 times minus 0.5 equals minus 0.25, negative. At x equals 4, 2 times 1 equals 2, positive. So the quadratic is positive on x less than 2 and x greater than 3. Because the inequality was greater than 0, endpoints are excluded. You draw open circles at 2 and 3. If it had been greater than or equal to or less than or equal to, you'd include the endpoints.
Quick check. So if it was x squared minus 5x plus 6 greater than 0, I'd include 2 and 3. Solid dots.
Exactly. Solid dots for greater than or equal to, or less than or equal to. And always write your final answer clearly. For example, x less than 2 or x greater than 3. Or in interval form, bracket -infinity, 2, closed bracket, union, open bracket, 3, infinity. If you're asked for exact form, use the roots as they are. Don't give decimals unless the question asks.
Why this works? Factorization gives the zeros. The sign of the quadratic between and outside those zeros is fixed because the expression doesn't change sign except at the roots. The parabola sketch is just a visual memory of that sign pattern. If the leading coefficient were negative, the sign pattern swaps, negative outside, positive between. So always check the sign of the x squared coefficient first.
Exam technique. How marks are awarded.
Exam technique. First, examiners want evidence of method. Typical mark split for a short quadratic inequality question looks like this. M1 for correct factorization, M1 for identifying the critical points and using them to set up intervals or a sign chart, and A1 for the correct final answer. On a 4-mark question, you might see an extra M1 for showing the substitution checks. If you only write the final interval without any working, you can lose method marks, even if the answer's right. So write down the factors, the critical points, and a quick sign test.
Common examiner pitfalls. 1. Forgetting to include or exclude endpoints correctly. That's an accuracy loss. 2. Mixing up the sign pattern because you didn't check the leading coefficient. 3. Writing the intervals incorrectly. For example, 2, 3 when you should have used 2, 3. If you get stuck midway, write down the factorized form and the critical points anyway. You often pick up method marks even if you can't finish.
So even if I can't finish, I should at least factorize and list x equals 2 and x equals 3. Yes, write it down. Marks are there for the taking. Let that sink in. Quick win, the 15-second substitute check and a mnemonic. After you find your intervals, pick a quick test value from each region and substitute into the original quadratic. If your signs match the inequality, your intervals are right. Mnemonic for endpoints: equals, solid, no equals, hollow. Think equals, solid dot, no equals, hollow dot. Practice that once and it becomes automatic under exam pressure.
Solid or hollow, that's so easy to remember.
Worked example, full past paper style question. Solve x squared minus 5x plus 6 greater than or equal to 0 and give your answer in interval notation. Step 1. Factorize. X minus 2 times x minus 3 greater than or equal to 0. Step 2. Critical points. X equals 2, x equals 3. Step 3. Sketch or sign chart. Parabola opens up, so positive outside. Test values. X equals 0 gives plus 6, x equals 2.5 gives minus 0.25, x equals 4 gives plus 2. So inequality holds for x less than or equal to 2 and x greater than or equal to 3. Hang on, let's be precise. Because the inequality is greater than or equal to 0, we include the roots. So the solution is minus infinity, 2, closed bracket, union, closed bracket, 3, infinity. Show you're working. Write the factorization, list the critical points, show one substitution for each relevant interval, then give the interval notation. Label method steps if you want. M1 factorize, M1 critical points and intervals, M1 substitution check, A1 final intervals.
Note, a student who writes only x less than 2 or x greater than 3 without union notation is less precise. Give the full interval form when asked. If you write decimal approximations unnecessarily, the examiner may question exactness unless the question requests approximations.
Recap and CTA. One sentence recap. Factor, sketch, sign chart, and always substitute one test value per interval. That's your routine to turn a tricky inequality into a method mark bank. If you'd like 3 practice questions with full worked answers to try this now, head to jcacademyonline.co.uk where you'll find the worksheet and model solutions in the show notes.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.